and sorry for those looking at the recording. You got here a little bit late, but you're just getting the start of the presentation, so we'll do okay. So depending on those technologies that we use, narrowband IoT, LoRaWAN, or Sigfox, it's going to have an impact on the range of sensors that you can buy and use. So the other question that we'll ask ourselves is, who owns the equipment that you're going to use? Are you going to own this communications equipment? Is it public equipment or is it private equipment? If you specifically want to have ownership of that equipment, you're probably going to look for a LoRaWAN solution, buy a LoRaWAN antenna. That's going to cost about, it's low enough cost, 1,500 euros, something in that range at the moment. Or you can use a public or private network. Now, your mileage may vary here, and if you're looking in remote parts of the world or even in remote parts of Ireland, or even at the moment, if you're looking in the cities of Ireland, you won't find a public network for IoT devices. So this 5G rollout will change that. Again, the NB-IoT is a 5G solution. So anywhere where you have 5G, you might be able to get access to that NB-IoT, but you'll probably get charged per device on, some kind of data plan. Secondly, if you don't own that communications equipment, they might store your data in their own servers, their own locations, and then you might have to access their server using their APIs to get that data to your own server. So that just brings in another layer of, I guess, complexity or workload that has to be done in order to get the data to your particular servers to use. The second question, who owns the equipment of the sensors? You might think, well, I've bought those sensors and I own those sensors. In different fields, you'll have different methodologies for this, but at least what's getting very popular in the agronomy side and for agriculture is this lease subscribe model. And as environmental monitoring is taking off, I can see it probably entering there as well, where you actually just lease the sensor and you subscribe to a data package from the company that leases that sensor to you, which is not ideal, certainly for a lot of research groups. And even if you do buy a sensor that belongs to a particular company, they actually might not want to send data directly to your database. Some companies typically want, and I'm talking about agriculture specifically at the moment that I've seen, but will move into other sectors, that they really want to send the data to their own servers and maybe distribute that information or your data to you on a smart app or something like that. Again, if a company wants to do that, you can use APIs to get that data back to your own server, but it requires a little bit of work and a little bit of knowledge. I mean, we're moving quite quickly through this. So the next topic we'll talk about is IoT data quality. So what are the quality issues with IoT specific sensors? Outliers, of course, just data that's kind of wrong, calibration errors, and drift error. So these are the same quality problems that you'll see in all data collection, or at least all instrumented data collection. I guess we'd ask, why is this, particularly pronounced in IoT data? Usually because the point of IoT data is that you're distributing a lot of sensors out to the field. And if you're distributing a lot of sensors out there, then you want them to be low cost. If you're implementing a low cost sensor, it might suffer from these problems more readily. So my research group focuses on automatic in-field calibration to adjust calibration error and looking at the long-term effects of drift error on sensors. So what are the benefits of IoT for I guess, solving these problems. As we said, or as I said indeed, that IoT solutions or implementations typically use a lot of sensors in the field. So these might be sensing, if not the exact same phenomena in the same location, very similar phenomena co-located or in very similar locations. So with that in mind, we may be able to use techniques or algorithms for co-location calibration or cooperative calibration so that we can calibrate each of those sensors amongst each other to get a better reading. And usually we've been using co-calibration for long-term drift errors to be able to determine if one of those sensors is going a little bit awry at any stage. This becomes even easier, or perhaps not easier, we get more accurate results if we have a gold standard sensor or a well-calibrated sensor in the field with our IoT sensors themselves. You might ask, why do we need IoT sensors if we have a well-calibrated sensor in the field? Well, if you have a very large space to, I guess, get information from, and a very large or wide deployment of sensors, you might have a lot of IoT sensors as they're cheap, but you might only have a single well-calibrated or gold standard sensor. So you might want to train and calibrate your IoT sensors off this gold standard for a period of time, move it to the next location, do some training and calibration, move it to the next location, do some training and calibration. Questions we're trying to really ask are, apart from what are the best techniques for doing this, is how much time do we need in a particular location to train our IoT sensors well? And how much time do we really need between training events? So will a sensor drift after months or years, or are there particular events that we know we haven't seen in the training instance that happen in our data that we have to retrain for? They're the kind of questions we're trying to answer at the moment. So what makes this particularly difficult in an IoT situation? Well, typically in IoT situations, we might be dealing with difficult communication locations, a wide dispersal of devices. So we might have missing data, missing sensors, what we might call holy data in the whole. And this isn't irreverent data. I'd say this is data with holes in it. So what we try to do, or a couple of techniques that we've looked at for in the field calibration, that instead of just calibrating directly from this holy data, much like a technique that you might use for cross-validation, we're using kind of imputation techniques to fill in those gaps of the data. Then we might want to calibrate or co-calibrate based on this imputed data set. Critically, well, it depends on how you're going to use that data. How I've been using it anyway is you impute the data sets with your algorithms, then you calibrate based on that imputed data set, but then I would get rid of this imputed data for the modeling. So, but it depends on how you're modeling indeed, but you can get rid of that data after it's calibrated. So the takeaways from this really, if we're flying through it, is if you're running an IoT data collection, deployment at some stage, do get in touch, because at the very least, I'll give you some advice on my experience. If you're running a data collection deployment with a gold standard or calibrated equipment, get in touch, because I might be able to find and roll out some IoT sensors that are sensing the same phenomenon that you're looking for. It might be able to, I guess, bolster your own data set and give me an idea or a chance to look at different use cases for the algorithms we've looked at. Finally, I'll go through this very quickly. So anybody who's collecting data, they go through a data pipeline from data collection, data processing, and then you're presenting that data to somewhere from a database, you're modeling and you're storing it. Do you process locally or in the cloud? Do you store that data before you process it? Is that stored locally in the cloud? Your final data store, is that local or in the cloud? That raw data that you've collected, is that necessary to be in your final data set? That depends on what agency. At what stage do you have to send that data to the agency that you're reporting to? Do they require that raw data, or do they only require processed data? Who's the owner of the data store? How are these data collected? Collected by hand, collected by instrumentation? Is it through, satellite or drone imagery? Are your sites that you're collecting data spaced apart? And do all of those types of data follow the same process or data pipeline? Probably not. So this is certainly from a project that I'm working on in SmartBog. You can see there that we've got 4 different work packages that are data collecting at the top. And essentially, there are 4 different mechanisms or 4 different data pipelines that we're using to collect data to the same location. So work package 1 collects satellite data, work package 2 is hand collected and instrumented, work package 3 also hand and instrumented, work package 4 is the IoT data collection. That has to be first processed by a third party, and then we're collecting it in real time. Work package 2 and 3, they pre-process data locally before they actually send to our final SmartBog database. Work package 1 takes imagery, but that imagery is available online already. And what we're supplying really is the bespoke processing on that imagery. What I'm really trying to get at here is that perhaps some of these pipelines can be modularized. So you all have different pipelines, but can we develop some kind of modular pipeline that we can use as a footprint, or maybe not a cookie cutter approach to implementing your data pipeline in your project? But are there similarities between them all? I'm not actually going to go through this, but this is an example of a pipeline that is very different to SmartBogs for an EPA project that NUIG are running. So you can see, well, I've run through it so quickly that you can't see, but there's data stored in 6 locations, not including like the European data agencies that want that data as well. Different means of collecting them and different time scales involved. And the data will be kept also for different time periods. So it's just another type of pipeline that we might want to look at and try to, analyze and find out what are the main steps of that. And finally, just what I'd like to say on this, if you're running some kind of data collection project, do get in touch. It would be interesting to see, identify and analyze the pipeline that you're using, see if something that we formalized can be reused. Some of the APIs and even some of the resources can be reused for, the collective good, to make things a little bit easier for the data collection process. And that's about it. I know we're really running out of time, so I'm going to leave it there. And that's pretty much all I wanted to say.
Thank you so much, Declan. It was really comprehensive, and yeah. So I open the floor to questions, and any questions to Declan? John?
Nice one. When you're talking about Internet of Things, what kind of scale of number of sensors are we talking about here? Are we talking hundreds or thousands? And over what kind of spatial scales can these networks of sensors be deployed? Could it go on a national scale, or is that too big a scale to do like national monitoring?
So with any individual antenna, let's say, you might get a 10-kilometer radius. Well, you can obviously deploy multiple antennas definitely over a national scale or a citywide scale. But for any individual antenna, you'll probably get a maximum of 10 kilometers. The kind of data that you're collecting might reduce that. If you're trying to send, let's say, an image, you may not be able to send a video, but the more information you're trying to send at any given time, the closer you'll have to be to that antenna. But yeah, the concept is it's scalable over a wide space and scalable to, yeah, thousands of devices also.
Great, thanks.
Any further questions? Toby?
Yes. Thank you, Declan, for your talk. Sorry, I joined a bit late, so I'm not sure if you have addressed my question. My question will be around the cost of the sensors themselves. How low is the low cost, especially for environmental sensing? So I'm actually interested in using this technology for ecosystem services sensing. So is this something you've already developed, and probably what's the cost range of this?
You're asking one of the quintessential questions in IoT. If you're deploying a lot of devices, how low is low cost? So I guess standard commercial sensors at the moment with IoT capabilities that you can run out off the shelf, they're still quite expensive. You know, you're looking at between 200 and 500 euro per device. So that's usually too expensive to run out, you know, 100, 200 devices. A lot of research and a lot of commercial groups, because this is starting to become much more relevant, but also with the 5G technology, the NB-IoT technology being rolled out to countries kind of more widespread, becoming more proliferous. There's a lot more commercial activity in developing IoT and low-cost sensors. So I can see that coming down certainly to between $20 and $50, 20 and 50 euro per sensor, and maybe further than that, but not further than that in the next 5-10 years.
Thank you. Another question I would like to ask is, so if I get IoT sensor from, let's say, from a manufacturer, and is there, excuse me, do they interact? So can I buy an antenna from another source and then use sensor from another manufacturer?
Absolutely. That'll depend on the technology used. So if you're using NB-IoT and you have an NB-IoT data plan or 5G, you'll need to buy a NB-IoT particular device. Now, a lot of manufacturers will make an NB-IoT device. You can choose between them, but it will have to be an NB-IoT. If you're using a LoRaWAN antenna, you'll need to buy a LoRaWAN device, but there'll be multiple manufacturers that will develop those.
Okay, thank you.
Thank you so much. Any further questions? No?
Great stuff.
Okay.
Well, like I say, that's a very high level overview. What'd be interesting is to see if there's other use cases out there for collecting data that we could kind of apply some of the algorithms, some of the learning tools that we've used on our data. It'd be cool to apply that to another use case.
So, for instance, would it be possible to use, because a couple of colleagues are using Raspberry Pis and Arduinos to use them? Because that will go to your question, Toby. These are very cheap like $20 sensors that you can use to take photographs of wildlife, or to just survey an ecosystem or something like that. So this would be the type of systems that can be used as well, right?
Yeah, yeah. Typically, the cheaper you get, the lower quality the data becomes. That's just the way it is. And the more need there is for data assurance. So some of these algorithms and techniques that I'm talking about, if you're using real low-cost sensors, we can try to improve that data using a couple of techniques.
Yeah, cool, excellent. Thank you so much. So if there's no further questions, we'll leave Declan, and let's give him a sort of a hint. Thank you, Declan, for
Thank you.
for everything. Thank you.
My pleasure. Thanks.
See you all. Bye bye.
Bye bye.